into the math portion of this chapter and figure out concentration units. In the previous video, I told you there were two types of concentration units, percent or molarity. Let's focus on, there are more than that. There's molality, there's parts per million, but in this class, we're just focusing on percent and molarity. All right, with percent, there are three types of percent. Percent by mass, which is percent mass of solute over mass of solution. So what we're going to write is we're going to write the mass of the solute divided by the mass of the solution. And remember, the mass of the solution is solute plus solvent. So if the problem gives you the mass of the solute and the solvent separately, you have to add them together to get the mass of the whole solution. So you put the mass of the solute on the top, you put the mass of the solution in the denominator times 100, and that gives you the percent by mass. Percent by volume would be, and then the mass of the solute, by the way, is in grams, and this is also in grams. Percent by volume is the volume of the solute, and this is going to be in milliliters, divided by the volume of the solution, also in milliliters, times 100. Okay? Percent mass by volume, and then these are used in different scenarios. Some are used in clinical settings, some are used in labs. In labs, we tend to do percent by mass. In clinical settings, they tend to do either by volume or mass by volume. So percent mass by volume is basically the mass of the solute in grams. Make sure you can see this. Divided by the volume of the whole solution in milliliters times 100. Okay, so that's how you calculate them. Let's do some examples of how you get these three different types of concentration units. All right, so let's say I told you guys that you have a solution that contains 10 grams of sodium chloride in 125 grams of water. And I ask you, what is the percent by mass? What do? Well, you put mass of solute on the top in the numerator, and then mass of solution in the denominator, and you multiply by 100. All right, so what is the mass of the solute? Just look at the terminology. 10 grams of sodium chloride in 125 grams of water. So this is an aqueous solution. This is the solute. This is the solvent. So you put your 10 grams up here. What's the mass of the solution? Water is not the solution. Water is the solvent. So you have to add the solvent with the solute to get the solution. So down here you put 135.0 grams times 100. This is 3 sig figs. This is 4 sig figs. You're going to have to round your final answer to 3 sig figs. I'm going to pick up my calculator. I'm going to put 10 divided by 135 times 100. And I get, if I can actually see without glasses, that would be great, 7.40174017, etc. So I round it to 3 sig figs. You get 7.41%. Okay, that's how you do percent by mass. So remember, if you're given solvent and solute, just add them together and you should, for the solution portion. Okay, to do percent by volume is also pretty straightforward. Let's say you had 10 milliliters of ethanol dissolved in water to make 225 mils of solution. So notice here they didn't give me information about the amount of solvent. They just said, all right, I've got 10 mils of ethanol, which is the solute, and it's dissolved in enough water, and I have 225 mil solution. So percent by volume would be the volume of the solute divided by the volume of the whole solution times 100. So you put your 10 mils divided by 225 mils. Notice I did not add them together. Why didn't I? Because the 225 is the solution. It's not the solvent. So they've already done the addition for us. So 10 mils divided by 225 times 100. I pick up my calculator. You put 10 divided by 225 times 100. And you get 4.444, 3 sig figs also, and you end up with 4.44%. Okay, that's your percent by volume. So that's the terminology here. And then finally, the last one deals with percent mass by volume. And for that one, it would be worded like this. Let's say you've got 10 grams of, 10 grams of sodium chloride dissolved in enough water to make, let's say, 325 mils of solution. What is the percent mass by volume? All right, so they gave us the mass, which is the 10 grams. They gave us the volume of the whole solution, which is 325 mils, and times 100. So same scenario, pick up your calculator, plug in the numbers, 10 divided by 325 times 100, and you get 3.01769, blah, blah, blah. We want 3 sig figs, so it'd be 3.08. 3.08%. And sometimes they'll write M over V or V over V or M over M. Sometimes they forget to do that. Okay, so that's how you calculate percent. Now, before we use percent as a conversion factor, let me introduce you to the other unit that you need to know how to calculate, which is molarity. Molarity, which is capital M, is basically moles of solute divided by the volume of the whole solution in liters. Okay, there's no multiply by 100. This is not a percent. Okay, so to get molarity, capital M, and if you're in the lab, you will see bottles labeled 6 molar solution or, 1.00 capital M next to it. That capital M means molar concentration. What is molar concentration? You get the moles of the solute divided by the volume of the solution in liters. How do you calculate molarity? Well, usually they will give you the grams of the solute. So for example, let's say you have 10 grams of sodium chloride dissolved in, that problem that we just did earlier? Let's do that. In enough water to have a 325 mil solution. Okay, so we're going to take that problem that we just did and we figured out the percent mass by volume, but now we're going to get the molarity. Okay, so 2 issues. They gave us the grams of the solute, but we need the moles of the solute. Do you remember in the previous chapter how to convert mass to moles? Remember how we used molar mass to convert mass to moles? So we need to get the molar mass of sodium. That's the one issue we have to do for the numerator. And for the denominator, we have the volume in milliliters. We need to change that to liters. So those are the 2 important things you must do in order to calculate molarity. Get moles on the top and have the volume of the solution in liters, not milliliters. All right, so we go to the periodic table. We look up sodium. Sodium is 23.0 grams. Chlorine is 35.5 grams. Add them together, and you've got 58.5 grams per mole. So 1 mole of sodium is 58.5 grams. So we've got, let me erase this, we've got 10 grams of sodium chloride. So we're going to have to convert that to moles. 10.0 grams of sodium chloride. I'm going to use our dimensional analysis. 1 mole of sodium chloride is 58.5 grams of sodium chloride. Okay? Do you remember we did this in previous chapters, I think? It was in chapter 6 out of Stoker. All right, so all you have to do is convert your grams to moles. Let's go ahead and do that. All right, 10 divided by 58.5, and you get 0.171 moles of sodium chloride. Now, your calculator says 0.17094101171. I'm going with 3 sig figs because that was our measured number that was given to us. And 0.1709, 9 is 5 or higher, so I rounded up. So here we go. So we have this many moles of sodium chloride. And we have 325 mils of solution. Remember how you convert milliliters to liters. 1 milliliter is 10 to the minus 3 liters. Remember that from way back, beginning chapter, metric conversion. Or you could just move the decimal 3 places to the left, so you have 0.325 liters. So I have my liters, I have my moles, I can now calculate molarity. So all you have to do is put this divided by this. So I'm going to erase this over here, the molar mass of sodium chloride. I'm going to write 0.171 moles divided by 0.325 liters. I get my calculator, 0.171 divided by 0.325, and I get 0.52615, etc., etc. I want only 3 sig figs, so your final answer is 0.526 capital M. So you either write capital M or you write 0.526 moles per liter. Either one of those is correct. Okay, so the best way to become really good at figuring out concentration units, whether it's percent or molarity, is to practice, do your homework, because the next video deals with using concentration as a conversion factor. This video dealt with finding concentration. That's the easy part. Using it as a conversion factor is a little trickier. So practice finding these first before we move on to the next one. Okay?